Hey, algebra students, in this lesson, we are going to be talking about how to solve quadratic equations by graphing. So, the first thing we're going to do in letters A, B, and C is learn how we can graph these quadratic equations on our own. But we can't actually graph these equations because look at these equations. Notice how many variables they have. They just have one variable, which means I can't put them on a coordinate plane in their current form. There's no y, so there's no y axis. What I need to do is actually graph the related function. What is the related function? Well, look what I do to make the related function. All I have to do is change the 0 to a y. And then what I'm looking for is where does that y equal 0? Wherever that y equals 0, that's the solution to my function. And then that'll be the solution to this. So what I mean is that's the solution to this equation. Now let's just take a look over here. Remember we talked about this before, graphical solutions to quadratic equations. If there's just one place where the y value equals 0, um, notice that this one just barely comes down and kisses the x-axis at 2. There's only one place where the y equals 0 for this function. That means that this would have one solution. Most parabolas, I think, that we're going to run into anyway, cross the x-axis in two places. So there's two places where the y value is 0. That means that there's going to be two real solutions to a parabola that crosses the x-axis. That means that for that quadratic equation, there's two solutions. And then lastly, some never cross the x-axis. So there's no place where this y value equals 0. And therefore, this one like that would have no solution. So if I ever graph them and they don't cross the x-axis, that means that there are no solutions. So one thing our book does is it gives us this excellent method for graphing parabolas just from the related functions. That's just an awesome way to graph a parabola. And then they turn around and in the practice problems, they give us this first equation that is just awful for using this method. Just awful. So we're going to do our best, but just so you know, the first and even the second one really don't work very well for the method that the book shares. So we're going to have to take the method with a grain of salt at first. However, I'm going to share with you. For most parabolas, the method shared by the book works really well for graphing. So the first step is to find the axis of symmetry of your parabola, which is x, the equation, the line, the vertical line, x equals negative b over 2a. Now, for one like letter C, that's really easy because negative b is the opposite of negative 10, so positive 10 over 2 times a. 2 is the number a is the number that's multiplying the x squared term. It's just 1. So it's going to be 10 over 2, or 5. The problem is that for a, we don't have just an x term like this. So actually what's going on in a and b also is that our x term is 0. It's almost like we have a plus 0x in there. And what that does is it means that our letter b, our coefficient b here, is 0, which means that our axis of symmetry is 0. Our axis of symmetry is the line x equals 0, which means it's the y-axis. That means that we're going to be symmetrical across the y-axis. Now, that's really nice because it makes a parabola easy, but it's not nice for this method because step 2, once we find the axis of symmetry, is to find the maximum or minimum point. And actually, this step works okay. So what I'm going to do is plug in this value I'm going to plug in my axis of symmetry value for x in my equation and see what I get. Well, 3 times 0 is just 0. Wow. This first parabola crosses the y-axis at negative 147. Negative 147. That means that it's going way down below where my graph is. Okay, so you can picture I'm gonna have this swoop that goes all the way down to 147. negative 147 and comes back up. All right, so the second step, like this is going to be really hard for me to graph. Now I could make a graph that counts up by tens, I suppose, and then I just go 15 units below the x-axis down to negative 150, and I could do that. I'm going to try to avoid that and see how this works out. Step 3 is also pretty terrible for these first two parabolas, okay? Step 3 is to find the values of y when the value, I'm sorry, of y when x equals 0. So you plug in 0 for x, but wait a second. We already did that because our axis of symmetry is at 0, so we plugged in 0 for x. Like I said, this is not the best example for the method in the book, but when we get to one like letter C, the method in the book works really well. All right, step 4 is going to be the most relevant step for us with this parabola. Find at least two other values on, we'll just say one on either side of the min-max for a minimum of 5 graphed values. So you should have at least 5 graphed values. You can maybe get away with 4. You should try to have 5. So you should have the axis of symmetry point, the value when y or x equals 0. And I'm going to say this should probably be 3 other values, at least one on either side of the min-max for a minimum of 5 graph values. That's going to be your best way to do this. All right, I only have one value so far that I could graph, and that's at 0, negative 147. That's way off my graph. Okay, here's what I'm going to do. I'm going to try plugging in 1 and see what I get for 1. If I plug in 1, is this going to become above 0? Is it going to be like in the positive? If I plug in 1, what happens? 3 times 1 squared is 3, so it's going to be negative 144. Still way too far off my graph. Let's plug in 2. 2 squared is 4. 3 times 4 is 12. 12 minus 147 is still going to be really far down. It's almost like negative 130 something, right? So that's way off my graph still. Let's try 3. 3 squared is 9. 3 times 9 is 27. 27 minus 147, still way off my graph, okay? Let's keep going. 4. 4 squared is 16. 3 times 16 is 48. And then 48 minus 147 is negative 99. I'm getting closer. Let's try 5. 3 times 5 squared. 5 squared is 25. 3 times 25 is 75. 75 minus 147, that's really close to negative 75. I'm getting there. Let's try 6. 6 squared is 36. 3 times 36 is 108. Let me just double check that to make sure. But I think 3 times 36 is 108. Yes. Okay. And then 108 minus 147, that's going to give me negative 39. Okay, let's try 7. Uh, Wait a second. What's going to happen at 7? 3 times 7 squared. 7 squared is 49. 3 times 49 is 147. I found my 0 just by trying. Okay, so here's my recommendation for this one. Just by trying to find my points, I figured out my 0 on the positive side is going to be 7, 0. When you find your zeros, you can actually kind of stop, because once you have your zeros, I mean, that's what we're looking for. Those are going to be the solutions to the equation. Okay, so I'm going to put that one there at 7, 0. I wonder if negative 7 works too. So let's try negative 7. Negative 7 squared is positive 49, right? Because negative 7 times negative 7 times 3 is 147. So negative 7 is my other solution. But we would expect it would have been 7 and negative, because if 7 was one solution, then negative 7 would have to be the other solution because it's symmetrical across the y-axis. And then my parabola just dips way off the graph. So if I were to try to draw this, I would have to just I wouldn't have 5 points because this parabola just goes way down here, goes way, way down, and then it comes back up on the other side like this. And I'm not drawing this great, but you can kind of picture what's going on here. It goes way down to negative 147. Okay. So this particular one, awful example to graph. Although I did get to show you how sometimes when graphing, you just figure out what your zeros are, and that's okay because that's what we're looking for. So the zeros for letter A should have been, if I did it right, 7 and negative 7. There we go. All right, let's do the next one. By the way, what you should be able to do then is plug in those values back into your equation. We did that for letter A already. You should be able to plug in the zeros back into your equation and verify that they do cause it to equal 0. All right, let's see if letter B gives us more luck with fitting on our graph. So first of all, we're going to find our axis of symmetry. Oh, look, it's 0. When I plug in 0 for x, though, at least I get a number that I can graph. I get 6. So I'm going to go ahead and put a point at 0, 6. Because 0, 6, it's the maximum of my equation, and I want to graph my maximum. Okay? Now the next thing is find the value when x equals 0. We just did that. It's the maximum. Find at least 3 other values on either side. We should have a total of 4 values. Okay, so let me do 1 and negative 1 next. Okay, so let's just make a copy of this. And let's see where 1 is going to land us. If I plug in 1 to my equation, I get 5 times 1 squared is 5 plus 6. That's going to be 11. Oh, man, I'm off my graph again. But at least this is not so far off the graph I can't place it. Okay. Um, what about if I do 5 times negative 1 squared is positive 1 also. This is going to be 11. Hey, I can already see a trend here. My parabola is going to look like... Here, let me draw a little better version of one. It's going to look like this, with this as my minimum, and then curving back up this way, something like that. So this parabola is never going to touch the x-axis. It started to go down toward the x-axis. It's not going to cross any zeros. I can tell by plotting just 3 points that this parabola is never going to have any zeros. So that means it has no solution. It's like this one right here. Let's see if that's true. No solution. All right, and then the one that I could actually graph, I'm going to count on this one to be my saving grace for this lesson, to show you the way that you should be graphing these parabolas to get good, like actual good results.